If you've been following this playlist from the beginning, you'll have learnt quite a fair bit about exponents by now, and you'll know that they were initially developed as a way to show repeated multiplication. For example, we've learned that 9 times 9 can be shortened to 9 squared because there are two 9s multiplied together. 9 times 9 is 81, so 9 squared is 81. But what if we wanted to work backwards? What if we're given the product, 81, and we want to find what factors multiplied by themselves gives you 81? Hi everyone, welcome to Sneezy Teachers, and today we're going to be learning about the inverse function of the square root. Let's start with an easy example. 4 times 4 equals 16. We've learned that we can write this as 4 squared equals 16 because there are two 4's multiplied together. But we can also see that 16 has an inverse relationship with the number 4. 16 is a perfect square because 4 times 4 is 16. Every number has factors, even prime numbers, which can only divide between themselves and 1. If we list the factors of 12, 16, and 18, we can see that they each have 3 pairs of factors, but the 16 is the only one which has a pair of twins. Two 4's multiplied together makes 16. When a number has factors that multiply by themselves to get that number, we call those factors roots. Bear with me here, this might get a little bit confusing. Basically, if 4 times 4 is 16, then 4 is a root of 16. More specifically, 4 squared is 16, so 4 is a square root of 16. 5 times 5 times 5 is 125, so 5 is a root of 125. Again, if we want to be specific, 5 cubed is 125, so 5 would be a cube root of 125. 3 times 4 is 12, but this can't be written in index form. 3 and 4 are two different numbers. They are not roots of 12. But 3 cubed is 27, so 3 is the cube root of 27. If 7 times 7 is 49, what is the square root of 49? 7. With me so far? Let me introduce you to your new friend, the radical sign, also commonly known as the square root sign. We use this sign to show or find the roots of a given number. So, for example, given that 4 squared is 16, the square root of 16 is 4. Given that 5 cubed is 125, the cube root of 125 is 5. If 3 to the power of 4 is 81, then the fourth root of 81 must therefore be 3. Notice that the little number in front of the radical sign tells us how many roots there should be. If we wanted to find the fifth root of 32, that means we're looking for a number that, when multiplied by itself 5 times, gives us 32. So blank times blank times blank times blank times blank is 32. What goes in the blank? The answer is 2. The fifth root of 32 is 2. Now, many of you are probably already familiar with performing square roots with just the radical sign, no 2 in front of it. This is because of convention, because in maths, we use the radical sign to find square roots more often than any other root. So the rule is, if there's a number next to the radical sign, then that's the root you need to look for. But if there's just a radical sign on its own, it's safe to assume that you only need to find the square root of that number. Before we wrap this up, there's one more thing about roots that needs to be explained. 4 times 4 is 16, but what about negative 4? Two negatives make a positive, so negative 4 times negative 4 is also 16, isn't it? This means that 16 has two square roots, 4 and negative 4. Every number greater than 0 has two square roots, a positive one and a negative one. But if we go to our calculator and use the square root sign, it only ever shows us the positive one. What gives? This, again, is due to convention. To make things a little less confusing, we've decided that the radical sign refers to the positive square root. The positive square root is also called the principal square root. There are two square roots of 16, but if you use this sign, you're just looking for the principal square root, aka the positive one. If you want to find the negative square root, you put a negative sign in front of it, which in this case would be negative square root of 16. And if you're looking for both the positive and the negative square roots at the same time, you would write plus or minus square root of 16. Now normally this is fine, but there's one thing you have to be extra careful with. The answer to this is 4, positive 4. But if you're given x squared equals 16 and you need to find x could be 4 or negative 4. So if you solve the equation like this would only be partially right, because you'd get your answer of 4, but you wouldn't get the equally valid solution of negative 4. If you're given x squared equals 16, x is technically plus or minus square root of 16. X could be either. unless we're given more information or context, of course. If we're trying to find the side length of a square that has an area of 16 centimeters squared, then logically x can't be -4, so we don't have to solve by finding plus or minus square root of 16. Just the principal square root of 16 is fine. Now, if you're feeling a little bit confused, then you may want to pause and rewind parts of this video, as this is a bit of a tricky concept, and it's really important that you understand the square root function before we go on to fractional exponents. There's only one more thing I'm going to cover today, and that's what if we're trying to find the square root of a number that's not a perfect square? Say, the square root of 3. So far, we've learned how to deal with perfect squares. 4 times 4 is 16, so the square root of 16 is 4. That makes sense. But what about the square root of 3? What multiplied by itself gives you 3? This is called an irrational number, like pi, because there's no neat way we can write our answer as a fraction or even as a repeating decimal. We know that the square root of 1 is 1, and the square root of 4 is 2, so the square root of 3 must be something bigger than 1 and just a little bit smaller than 2. You're not expected to be able to mentally calculate this. This we're going to use a calculator for. If we plug in square root of 3 into our calculator, we'll get 1.732050876. See how it just goes on forever and it's not repeating either? We have to shorten this. It's way too long, so I'm going to shorten it to 2 significant figures and make it 1.73. So the square root of 3 is roughly 1.73. Bigger than 1, closer to 2, just like we predicted. Some square roots you can do in your head if they're perfect squares, but if they're not, like the square root of 3 or 5 or 10, you'll need to use a calculator to get an approximate answer. Think you've got it? Try a few questions yourself and see if you can find the answer. That's it for today, guys. We've only barely touched the surface of square roots, but this video is getting long enough as it is. So I'll just leave you with this question, which I'll answer in my next video. We know that the negative square root of 64 is -8. But what if we have the square root of -64? Is that possible? If not, what about the cube root of -64? Is that possible? Let me know your thoughts in the comments, and I'll see you next time at Sneezy Teachers. Thanks for watching. Bye!